In this video, we're going to look at an application of square roots. Specifically, we're going to use the Pythagorean theorem to find the missing length of the given triangles. Round your answer to the hundredths place when needed. So notice we have three formulas here. These two are actually very similar, and these ones are for solving for a leg, and this one is solving for the hypotenuse. So here I drew a generic right triangle. You know the right angle because it's indicated by this little square. That's how we indicate a right angle. But also notice that these two lines are what we call perpendicular. So you can think of it, if you look at the corner of your room, unless your walls are slanted, it's how the wall meets the floor. Okay. So to start, we call the side that's opposite the right angle, so I'm going to draw an arrow, the hypotenuse, and we label the hypotenuse with the letter C. These two sides we call the legs, and you can call them, we call them A and B, but you can call them, I'll call this one A and this one B, but it doesn't really matter. We could have called this one A and this one B. So in general, we just need to distinguish between the legs and the hypotenuse. So let's look at the first one. So I'm noticing the question mark is here, and that's the side opposite the right angle. So that means we're solving for the hypotenuse. So I'm going to use this formula right here. Okay. So basically the A and the B are 3 and 4. And if it helps, you can write this. Okay. Again, it wouldn't matter if we called B3 and A4 in the formula. It works out the same as long as you're consistent along the way. Okay. So C, or the question mark here, equals the square root of 3 squared plus 4 squared. Now the square root symbol acts as parentheses, meaning that the first thing we need to do is find this quantity. And we can put this quantity directly in the calculator. So let's do that. Okay. So depending on what calculator you use, this one's pretty generic. But I have 3, there's an x squared button, so that's going to square it. So that says square 3 is 9, plus, now I'm going to hit 4 and hit that I want to square it, and it says plus square of 4 is 16. And then when I hit equals, it gives me the total. So this equals the square root of 25. Now you may know that the square root of 25 is 5. The square root is asking us what number do I multiply by itself to get 25, and that result is 5. To verify that on the calculator, on a lot of calculators you hit the square root button, then you enter the number, but on this one I have the number, then I hit this square root button, and notice this has a T at the end. When it was squaring it, it just said SQR when we hit this button. This one says SQRT, which means square root of 25 is 5. Let's look at the next one. Okay, so here, the missing side is here, and I'm noticing again that we're missing the hypotenuse. Okay, so our missing side, which we're calling question mark, is the square root of the sum of the squares of the other two sides. So 5 squared plus 7 squared. Again, you could put this in either order, and you could see that also because addition is commutative. So now, 5 squared plus 7 squared equals 74. So now we have the square root of 74. Now 74 is not a perfect square, so our result is going to be an irrational number. So to find that and approximate it to the nearest hundredth, I'm going to click this button, and to 2 decimal places it's 8.60. That's a 2, so I'm not going to round up. So I'm going to put approximately equal to 8.60. And I like to put the 0 there because that lets me know that I did round to 2 decimal places, okay, even though 8.6 is equivalent. Now let's look at the last one. Here's our missing side, okay, and I'm noticing the hypotenuse. So notice I always look for the hypotenuse first. because the other two are both legs. So if I know I find the hypotenuse, the other two are legs. So the hypotenuse is given here. It's 9. We know one leg is 6 and the other is unknown. Okay. So you can think of either of these formulas. We're not calling it A or B, but notice the general idea is the hypotenuse value squared, so you always start with that, and since it's subtraction, it matters that you start with that first and not the leg. Okay, and then you're going to subtract the square of the leg. So question mark equals the square root of 9 squared minus 6 squared. Okay. So now let's compute this value under the square root. So 9 squared minus 6 squared equals 45. And again, 45 is not a perfect square. It's between, 45 is between 36 and 49. So this is going to be between 6 and 7, but let's get a better approximation. I will hit the square root button, and to 2 decimal places, we have an 8 in the thousandths place, so I'm going to round up to 6.71. So to sum up, to find the missing side of a right triangle using the Pythagorean theorem, determine the hypotenuse, okay? Determine which side is missing. If the hypotenuse is missing, you use this formula. If a leg value is missing, you use this formula. You add the sum of the squares or take the difference if you're looking for a leg, and then you find the square root last.